All right, for number 14, solve and graph 2 absolute value of x minus 7 plus 5. So again, got to get the absolute value of x minus 7 by itself first. So I would need to subtract 5 on both sides. Bring down 2, absolute value of x minus 7 less than negative 4. Then divide everything by 2. Left with the absolute value of x minus 7 less than negative 2. Now we write our two cases. Or I'm sorry. This is a less than scenario. Oh no, I hit the wrong thing. This is a less than scenario. So we write it as positive 2, because you do the opposite first, less than x minus 7 less than the original negative 2. Now get x by itself in the center. So add 7. You would get 9 is less than x less than 5. Now, is that a true inequality? Is that? No. This is a false inequality. You can't have 9 less than 5. So this has no solution. Let's see if what would happen if we were to plug back in to our original equation. Any number between 5 and 9. Let's see what would happen. 2 absolute value. Let's go with 6 minus 7 plus 5 less than 1. That's negative 1. 2 times the positive 1. That would be 2 plus 5 less than 1. 7 less than 1. That's false. So this has no solution. You can't you can't do that. You just can't. It doesn't make sense. 9 is not less than 5. And I showed you what happens if you take a number within this that's in between 9 and 5, which would be 6, and there's other numbers, but it doesn't produce a true inequality. So no solution. So we're going to use this table. Again, it's hours practice and free throws to answer 15 and 16. Describe the correlation for the scatter plot that can be constructed from this data. So let's get our calculators and let the calculator show us the plot. Again, you need to clear out your list first by hitting Stat, Clear List for second one for list 1, comma, second 2 for list 2. Hit Enter, and then you're done. Now you can go to Stat, Edit, to enter the data. So we have 1, enter, 3, 4, 7, 12. We would have 0, 4, 6, 16, and 19. Now, I'll show you how to get the plot so we can look at the data on the scatter plot. So from here, you would hit second, y equals 1. Right now, the plots are turned off. We want to turn them on. When it says type, we want the first type, which is scatter plot. Where are our x's in list 1? Where are our y's in list 2? Make sure you come over to y equals and make sure there's nothing there. There is, so let's clear that out. And now hit graph. Notice we only see 3 of our dots, and we know there's supposed to be 5 in this table. So we go to window to adjust our window settings. For x min, that's asking us what is the lowest x's we have in this table. Since x's are hours practiced, the lowest one we have in the table is 1. So let's go a little less than that. So let's say 0. X max is what are the highest x's you have in this table or data set. Our largest x right now is 12. So let's use 20. That's a good number. You don't want to start and stop exactly at the values. You want to give it a little more extra room. Now for y min, our lowest y is 0, so 0 is a good number. And our largest is 19, so again, let's use 20. Now hit the graph again, and now we can see all 5 data points. So when I look at my scatter plot, I see that my points are constantly increasing from left to right. So since both values are increasing from left to right, that's a positive correlation. If you want further evidence, go to mode and turn your stat diagnostics on. Oops. Enter. And then do a regression. So stat calc 4 and then calculate. R is your correlation coefficient, and R is about 0.9567, which again is a strong positive. The closer it is to 1, the closer it is to being a, a straight, perfect straight line. So it's a strong positive relationship. So that's just further confirmation that what I was looking at in my data on my scatter plot was correct. Number 16 says, what is the appropriate prediction equation for the situation described in 15? So we kind of did that when we did our regression. So let's write our equation down as well. So y equals 1.82 if you round to the second decimal place properly. X minus 0.81 would be the equation that represents this data. Again, when b is negative, don't put plus negative, just simply put a minus sign. Number 17, which equation below could be a prediction equation for the data points shown in the scatter plot at the right? So we're going to, instead of having a table, we're given the graph. So let's take the graph information and try and produce an equation. So let's clear our list. Stat, clear list. Second one for list one, and second two for list two. Enter. So our first data point, stat edit to get our list on the screen. This first data point is, well, let's look at our tallies. We jumped 200, 400, 600. So each line represents 100. And then for our y-axis, each line represents 12. So the first data point is about 100 for our x's. So 100. The second data point is at 200. The third is at 400. And the fifth is over here at 800. Now, for the first one, the one on the 100 line, it's less than 12. So let's say about 10. For the one on the 200, it's less it's less than 24 and a little more down than the first dot. So let's say 20. For 400, it's less than 48. So let's say 44. Half we are Since each line represents 12, halfway would be 6. Does that make sense? So I know that just kind of use a little reasonableness. So for the one on the 800 line, it's halfway between 108 and 96. So that means it's about 6 spaces from 96. So that would be 102. And if our points are off slightly, it won't change our equation by that much. So now that I have the data in my list, I'll run the regression by going back to stat, calc, linear regression, and enter, 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 calculate. So the best equation we have, and let's just write it down from the calculator. So y is equal to 0.13. So that eliminates B and C, X, and then minus 5.83. Whoa. Okay. So let's go with A. A is the closest one to our data points. Because of the fact that there's a minus for our intercept instead of addition. But again, it's it's going to be off because our data points are not exactly right on target, which again, it wanted to know which one would be the best answer choice. So that's the closest one to being correct. 18 would like us to sketch this inequality. To use our calculator to graph this function, we need to make sure y is by itself first, which it is. Great. So go to our calculator, go to y equals. There's nothing there. Oh, go to second y equals. And let's turn our plot off because we don't need the data plot anymore or the scatter plot anymore. So now we're good. Back to y equals. And we're going to type in 3 absolute value. So math num1 and then x minus 1 inside the absolute value and graph. So if you want to convert back to the basic window that you're used to seeing, go to zoom, standard, so 6, and it automatically converts it back to its original screen that you're used to. So I know we adjusted our windows when we did our scatter plot, but if you want it to go back to the regular window that you're familiar with, just again, I hit zoom standard. So there's our absolute value. It's pointing upwards. So we need to make sure we get the vertex, that lowest point down there. We need 1 point over here on the left and another point on the right of the vertex. The x value for our vertex looks like it's at +1. So when we look at our table, we're going to look for +1 on our table. So second graph produces a table. So yes, our vertex was +1. So our vertex is +1 and our y value is 0. And then again, pick any points on the left and the right of our vertex. So I'm going to use 0, 3, and I'll use 2, 3. So on our graph, label those 3 points, please, with their ordered pair. If you want to draw the axes, you can, because we're going to now need a test point. And as always, please use 0, 0 if it's not on the V, and 0, 0 is not. You also want to get in a good habit of plotting the test point and labeling it T so you don't forget where it is. And now when we use our test point, we need to put it inside, substitute it into the original equation or inequality. So that would be 0 is greater than or equal to 3 absolute value of x minus 1. So again, I'm turning x into 0 as well. So bring down the 0 on the left, greater than or equal to, and then use your calculator, totally fine, to type this in. If you don't want to use a calculator and you understand how this side works, then great. I'm not going to use a calculator, it's just going to take a little longer. So that'd be 3 times the absolute value of -1, essentially is what the calculator is doing. So that's 3 times +1. So 3 times +1 is 3. Now, is that a true statement? Is 0 greater than or equal to 3? No, it's not. That's false. So since it's false, we're going to shade the area that does not contain our test point. So that happens to be inside our V. Because again, our test point is down here. So we shade the region that doesn't contain our test point, and that is the inside of the V in this case. Number 19 wants to know what is the equation for the absolute value inequality graph below. Ooh, I'm sorry. For number 18, go back. I forgot to mention that the boundary, the V, could either be solid or dashed. In this case, it's solid because that equal to is present. So we did a good job. I'm so sorry. So remember, going if it has the equal to bar, make it a solid boundary. If it doesn't, it'll be a dashed boundary. All right. Now that I know that, for number 19, we have to try and figure out what is the graph or the equation inequality. Well, I do know that it's a solid line, so we know it's going to be less than or equal to or greater than or equal to just from that information. Our vertex is here at 3, 0, and it's flipped upside down, so we know there's a negative involved when it's flipped upside down. So if we remember, our parent function started at 0, 0, and it faces up, right? So our parent function shifted right 3 units. So we know the absolute value sign is a liar. So when you go right, that's an x minus 3 scenario, not an x plus 3 because you do the opposite. And then again, um, it flipped over the x-axis. It reflected over the x-axis. So we know that there's a negative involved, and the negative is out in front of the sign when it flips over the x-axis. So let's let's see if some of the points on this graph make sense. So I see another point here at 0, -3. So let's see if that makes sense with our current equation. So basically what I'm saying is I think I've found my equation. I just don't know my inequality sign yet. So I don't know what comes here, but I think it's negative absolute value of x minus 3. So let's test out this theory using some points on the line. So I see -3 for y if x is 0. All right. So -3, 0 minus 3 is -3. The absolute value of -3 is +3, so that is -3. So that is correct. But let's find, so that looks like it would work for the equation. Now for the shading, we have to decide, is it less than or greater than? So let's pick a point. Let's pick our test point, our normal test point, 0, 0. All right, so that would be 0. We don't know what symbol it is yet. The shading will help us determine the symbol. And then we have our negative absolute 0 minus 3. So 0, question mark. Again, that's going to give me a negative 3 on this side. I've already calculated that. So it didn't shade the side 0, 0 was on. So we need this to be false. So in order to be false, it should be a less than or equal to negative 3. That's a false statement. 0 is not less than. That's false. So our final equation for this graph should be y less than or equal to negative absolute value of x minus 3. Again, we wanted our test point to be false because we didn't shade the area that contained our test point. We shaded every other region. So that's why I had to use less than. I would have used greater than if the 0, 0 point was included in the shading. And our last question. Enrique's company pays Salim to advertise on Salim's website. Salim's website earns $15 per month plus 5 cents every time a visitor clicks on the advertisement. In order to have the website be profitable, they must make at least $50 a month. Write an inequality that best describes this given situation. Okay, it's a lot going on so far. So the website earns 15 a month. So plus 0.05 every time a visitor clicks. So for 5 cents for a click. For each click, it's 5 cents times that. In order to have the website be profitable, they must make at least $50 a month. So at least means $50 or more. So we need to be greater than or equal to $50 to be profitable. All right, so $15 plus 5 cents per click should be greater than or equal to 50. That would be the inequality that describes this scenario. $15 plus 5 cents per click. This concludes the review for your test. Happy studying. Make sure you ask questions if you don't understand. Good luck.